This is 6.3b of algebra. So we've looked a little bit at elimination, and the ones that we've done always work out perfectly, right? Either you add or you subtract them, but you eliminate one of the variables without having to do anything else. So we're going to start looking at some situations where elimination is a really good decision, but it's going to take a couple extra steps before we can actually eliminate the variables. So we're going to look at this problem here. I'll copy up here. Negative 5x minus 2y equals 6. And 3x plus 6y equals 6. Okay, so just looking at these, our x's aren't going to cancel and our y's aren't going to cancel. If you remember, it cancels out when the numbers are the same, but the signs are different. So one is positive and one is negative. So both of our x's have different numbers, and one's positive and one's negative. So we've got the positive negative thing, but they're different numbers. For our y's, we've got positive and negative, but they're both different numbers. So what would be easiest for us is if we only have to multiply one equation by some number so that they'll cancel out. So I can't multiply 3 by anything to get to 5, but I can multiply 2 to get to 6, right? I can multiply 2 times 3 and that'll give me 6. So what I'm going to do is I'm going to multiply that first equation times 3. So let me write it out down here. So I need to multiply the whole thing by 3. So 3 times negative 5x equals negative 15x. 3 times negative 2y equals negative 6y. And 3 times 6 equals 18. So now I'm going to write the other equation underneath it. And I'm going to add them. So negative 15x plus 3x equals negative 12x. Negative 6y plus 6y is 0. So this equals, and then 18 plus 6 is 24. So I'm going to divide both sides by negative 12. And I get that x is equal to negative 2. Remember, that's not the end. We need to plug that back in. I'm going to plug it back into, how about the second equation? Doesn't really matter, but 3 times negative 2 plus 6y equals 6. So this is negative 6 plus 6y equals 6. I will add 6 to both sides. And I get that 6y is equal to 12. And when I divide by 6, I get that y is equal to 2. So our answer is the point negative 2, comma 2. That is our solution. Okay. So sometimes we only have to multiply one equation, but sometimes we'll have to multiply both equations. So we're going to look at this system. Again, I'll write it up here. 4x plus 3y equals negative 19, and 3x minus 2y equals negative 10. So you can see that our x's and our y's aren't going to cancel out, right? Our x's are both positive. One's a 4 and one's a 3. Our y's have a positive and a negative, but they're different numbers. So we got two options. We can try to get rid of our x's, or we can try to get rid of our y's. If we tried to get rid of our x's, both 4 and 3 go into 12, right? So I could multiply the top one by 3, and that would get me 12x. But I'd need to multiply the bottom one by a negative 4 to get a negative 12x, right? So they cancel out, or you can make the top one negative. But if we went for our y's, they're already positive and negative, so we'd have to multiply the top by 2 and the bottom by 3. So I'm going to choose that route so I don't have to mess with multiplying by negatives, but you could go for the x's if you want. So this top one I need to multiply by 2. This bottom one I need to multiply by 3. So 2 times 4x plus 3y equals negative 19. So I need to multiply everything by 2. 2 times 4x is 8x, plus 2 times 3y is 6y, equals 2 times negative 19 is negative 38. Then I need to do my other equation. So I need to multiply the second one by 3. 3x minus 2y equals negative 10. So 3 times 3x, that's 9x. 3 times negative 2y, that's negative 6y. 3 times negative 10, that's negative 30. So let me rewrite my two equations. Here's where we finished them, right? There's the first one. There's the second one. So I'm going to write those out so that I can add them more easily. 8x plus 6y equals negative 38. 9x minus 6y equals negative 30. So I'm going to add these. 8x plus 9x, that's 17x. And 6y plus negative 6y, well, that's 0. So this just equals, and negative 38 plus negative 30, that'll give me negative 68. And then when I do negative 68, I need to divide by 17. And I get that x is equal to negative 4. Okay, so I've got my x. Different options on where you can go plug this in. Your best decision is plug it into either this first one or the second one. You could, if you wanted to, plug it into these ones that you multiplied. There's not a really good reason to choose one of those, and you might have accidentally gotten it wrong. So I'm going to go with one of those first ones. Let's go for the top equation. So 4 times negative 4 plus 3y equals negative 19. So that's negative 16 plus 3y equals negative 19. If I add 16 to both sides, oops, I'm running out of room. When I add 16 to both sides, I get that 3y is equal to negative 3. And divide by 3, and we get that y is equal to negative 1. So we get the point, negative 4, comma, negative 1. And just a reminder, whenever you get an answer to one of these, whenever you get a solution, if you're a little hesitant on if you got it right or not, you can always go back and plug it in and make sure that when you plug it into both equations, it comes out true. You get something like 9 equals 9, negative 5 equals negative 5, right? If you get something like 2 equals 3, then something went wrong and your solution is not, in fact, a solution. So you're going to have to go back and check your work then. Okay. Finding the number of solutions. So, remember number of solutions. Sometimes there's one, and that's when they just cross at a point, right? Sometimes there's infinitely many, and that's when our two equations happen to be the exact same equation. They just are written different. Or you can get no solutions, and that's when we have parallel lines. So, we are going to solve this guy here using elimination. So I'm just going to write it out. Oops, let's go a little smaller. We got negative 2x plus 5y equals 7. And we got negative 2x plus 5y equals 7. Okay, so we can't just add these and cancel them out. So we could just subtract them. If you don't like subtracting, another way to do it is choose one of them and multiply through by negative 1, and then you can add them. That's the same thing. I'll go through subtracting with you. So, negative 2x minus a negative 2x. Remember, when you're subtracting a negative, that's the same thing as adding. So this is negative 2x plus 2x. So this is just going to be a 0. And then we've got 5y minus 5y. Well, that's just another 0. Whoops, I copied my equations wrong. Those aren't both 7s. This one's a 12. There we go. So 7 minus 12, that's going to equal negative 5. So we get 0 equals negative 5. Is that true? Does 0 equal negative 5? No. So these are parallel lines, which means there are no solutions. If you get something that's true, like 4 equals 4, that means that there are infinitely many solutions. A case where you'd have one solution, well, that's like all the problems that we just did. You'll get out x equals something and you can plug in back for y. So here's a little flow chart that's in your book as well, helping you to figure out when you need to multiply or not. If you can just add them or subtract them and they cancel off, do that. If you can't do that, figure out if you can multiply just one equation by a number so that when you add them they cancel, or subtract them they cancel out. And if you need to, you might have to multiply both equations by some number. There's your homework.